Hello everyone, myself Akash Reddy from SPC College, CSE-AI branch. So today's topic is about explaining typical ResNet architecture which comes under CNN architecture and which follows CNN architecture. So first let's go through the introduction of ResNet architecture. ResNet stands for Residual Neural Network. It was first introduced by Microsoft Research in 2015. ResNet is known for its ability to train very deep neural network, shortly known as DNN effective, is what's shown in the image, which is having a multiple layers. Let's go to the motivation of residual learning. Traditional DNN suffers from a vanishing gradient problem. Residual learning aims to address these issues by using a short connection. These short connections allow the network to learn residual functions. Let's go to the image. At first, we have three input nodes. In the middle, we have four hidden nodes. Last, we have two output nodes. At the input nodes, it is getting connected to all the four hidden nodes. Next, all the four hidden nodes are getting connected to two output nodes. The connection known as links. Building a block of ResNet. The basic building block of a ResNet is a residual block. A residual block consists of two conventional layers with a short connection. That is what's shown in the image A. It is having a two connection, one cross one and a batch normalization. These are the two blocks. The output of the shortcut connection is added to the output of the second conventional layer, which is shown in the image B. Next, we are having the stacking residual blocks. ResNet architectures typically stack multiple residential blocks. Deeper ResNet models have hundreds of layers. Stacking residual block allows the network to learn complex features. Next, let's go through the skip connection. A skip connection in ResNet allows the network to bypass one or more layers. Skip connection helps with the gradient flow and alter the vanishing gradient problem, which was the major issue when it comes to other DNN, deep neural networks. Skip connection enables the training of very deep networks. At the first half of the image, we have convention and pooling that comes under the encoding. Then the second half, after the skip connection, we have the decoders expanding the path, transference convention. Next, let's go to the residual learning concept. In the residual learning, the network learns residual function instead of directly learning the desired underlying mapping. The residual function is the difference between the input and the output of a block. This approach simplifies the learning process and improves the performance. At first, it takes the X, next a weight layer and a weight layer. Types of ResNet architecture. ResNet architecture comes among the different depths such as ResNet 18, ResNet 50, ResNet 101, and ResNet 152. Deeper ResNet model tends to have a better performance, but the ResNet requires more computation resources. The choice of ResNet architecture depends upon the specific task and the given dataset, and furthermore, the ResNet majorly comes under the CNN architecture, which works under the ResNet. Training a ResNet model requires a large dataset and significant computational resources such as dataset, input data, and training models. Much more. Techniques such as data segmentation, batch normalization, and learning rate and scheduling are commonly used. Pre-trained ResNet models are available for transfer learning on a new data set. Next, we have the benefits of ResNet. ResNet architecture have been widely adopted in various computer vision tasks such as image identification and object identification, color identification, and much more. The tasks which are majorly done by a computer vision to camera. ResNet models have achieved a state-of-art performance on an image classification benchmark. ResNet, skip connection, and residual learning concepts have influenced the designs of other neural network architecture. The other neural architectures such as RNN, CNN, etc., and ANN also. The applications of ResNet are first we have the image classification, object detection, and transfer learning. At first, let's go through the image classification. ResNet models are widely used for image classification tasks such as identifying object or a sensor within the images. They have achieved a state-of-art performance under benchmark datasets like ImageNet, much more. Object detection. Next. ResNet serves a backbone architecture for many object detection systems, such as faster RCNN, or conventional neural networks. In VIVO, you only look once, and SSD, single shot multi-box detector. The D feature learned by a ResNet are crucial for accurately localizing and classifying the objects within the images. Transferring learning is the last application. Pre-trained ResNet models trained on large-scale datasets like ImageNet are commonly used for extraction features for transferring learning. By fine-tuning these models are smaller domain-specified dataset, one can achieve good performance even with the limited labeled data. At last, let's go to the conclusion. ResNet architecture have revolutionized deep learning by enabling the training of very DNN, deep neural networks. The use of skip connection and residual learning have proven to be effective in improving the gradient flow and learning performance. ResNet can to be a popular choice for various computer vision tasks due to its performance and vast clarity. Thank you.